Hello and welcome to Kubernetes at Scale running multiple clusters. I'm Kaslin Fields, and I am a developer advocate for GKE, or Google Kubernetes Engine. I'm also an ambassador of the Cloud Native Computing Foundation and a member of the Kubernetes Open Source Special Interest Group for Contributor Experience. And I focus my work on containers, cloud native, DevOps, and especially Kubernetes topics, which is what we're going to talk about today. So today I'm going to go over kind of a baseline of what is Kubernetes and why are we talking about it. Then we're going to talk about multi-tenant single cluster Kubernetes architectures, and then the limitations of those, and thus the reasons for multi-cluster architectures in Kubernetes. And then we're going to do a little bit of an introduction to what capabilities exist for Kubernetes multi-cluster architectures today. And then we'll recap everything to make sure that you've got it. So we're going to start off, like I said, with a bit of an overview of what Kubernetes is and why we're talking about it. So if you're a Kubernetes pro who's been using it for a long time, bear with me for a couple of slides while I go over a quick analogy and some highlights of what Kubernetes is. I'm going to refer back to this later in the presentation as we talk more about more complex Kubernetes architectures. So it'll come back into play later. So when I give Kubernetes and container introductions, I have a few analogies that I like to use to help make sure that the concepts stick. And one of my favorites is talking about containers as cookies. There are several reasons that I do this. For one, the entire point of using containers is to run some form of application. Just like the entire point of a cookie is the chocolate chips. The rest of the ingredients are really just there to help the chocolate shine, just like in containers where you are trying to run some kind of application, but it has dependencies in order to be able to run. So you take the application, like the chocolate chips, and its dependencies, like the rest of the ingredients, and you mix them all together and bake them up into a convenient portable package. This is one way that containers are used as a packaging mechanism. So I like to use this analogy to help explain some of the benefits of containers, how they help you run your applications and make them portable. And there are several other reasons that I like this analogy, but I like to build on this analogy as I talk about Kubernetes. So Kubernetes is a container orchestrator. It orchestrates containers. So if we think about containers being like cookies, Kubernetes is a bit like a cookie factory. Really, it's like a cookie business, managing the logistics of running a cookie business at scale. So this is similar to what Kubernetes does. It is a tool for managing the logistics of running containers at scale. So to do this, it provides an abstraction. Your containers, your applications are ultimately running on some kind of machine in the end, some kind of computer. But Kubernetes allows you to connect many machines together and abstracts away the barriers between them, allowing you to interact with many machines as one unified Kubernetes cluster. So in order to orchestrate your workloads that are running in containers, Kubernetes provides an API full of tools designed to allow you to run your workloads efficiently. So let's take a moment to go over some of the tools that Kubernetes offers that allow you to do this. One is a deployment. This is kind of the essential component of Kubernetes that you need to know about when you're starting to run containers in it. So this example on the screen here is a YAML file that declaratively defines a Kubernetes object called a deployment. So deployments are the most common tool used to run containerized workloads in Kubernetes. There are a few others, which I'll mention in a minute. You can see the type of Kubernetes object that we're creating, a deployment, highlighted in red on the second line. And if you look toward the bottom of the file, you'll see another red highlighted section called containers, which defines what application or container we're actually running. So you can see that in this case, the containers that we're running that will be managed by this deployment are running Nginx. I'm not going to dive into the details of deployments or any specific Kubernetes objects. Well, one specific Kubernetes object, but we'll get to that in a minute. But I just wanted to make sure that you have some kind of connection point for understanding how Kubernetes runs your containers and kind of manages them so that you can run them at scale across your Kubernetes cluster. Of course, there's a lot more to orchestrating containers at scale than this. So accordingly, Kubernetes has many other tools and capabilities. Here are just a few of the capabilities and concepts that Kubernetes provides to make running workloads very convenient. You may have heard Kubernetes referred to as a platform for building platforms, and I think that's a great way to think about it. Kubernetes provides all these many tools and capabilities which allow you to build all sorts of workloads and even other platforms on top of it, while it abstracts away some of the complexities of managing the underlying infrastructure. So let's hit some highlights here. Replication controllers is a term that it's kind of an umbrella term that incorporates several Kubernetes objects, which are used for describing and managing containerized workloads, such as the deployment definition we just saw. There are also several other types for more specialized workloads, such as stateful sets for workloads with persistent storage needs, and daemon sets for workloads that need to be run on every machine in the cluster. We'll also need some way to connect with our workloads that we're running on Kubernetes. So that can be done either with a Kubernetes service, though at scale you may need to use the updated implementation of Ingress for Kubernetes, which is called the Gateway API. If you've been using Kubernetes Ingress, definitely check out the Gateway API, which is kind of the evolution of that concept. As Ingress has grown in popularity, it's kind of evolved a bit into a new Gateway API. So those are two tools that you can use to interact with your workloads that are running on Kubernetes or manage the ingress to them. And while stateful sets provide some tools for managing applications with persistent storage needs, you'll still need to manage Kubernetes' perception of the actual storage volumes, which will mean that you'll be using persistent volume and persistent volume claim objects in Kubernetes. And Kubernetes even provides tools for managing various types of automatic scaling for your workloads using pod autoscalers. But two things on this list that I really want to go over, which are key to understanding multi-cluster architectures and use cases, are namespaces and role-based access control, or RBAC. So let's dive into those a little bit. Now that we have something of a common baseline for understanding what Kubernetes is, let's dive into namespaces and RBAC a little bit more so that you'll understand kind of what the limitations are of single cluster Kubernetes and why you might want to do multi-cluster. So this diagram shows how a Kubernetes namespace allows for grouping and isolation of Kubernetes objects such as pods and services, which we talked about earlier, So earlier we talked about how Kubernetes abstracts underlying machines to create a unified cluster view. In this diagram, we have a cluster made up of compute nodes, which are highlighted here in red. These can be VMs, cloud instances, or bare metal machines. They can be little machines like this one I have on my desk. The important thing is that they are the hardware where our containers are actually going to run. So you can see several Kubernetes pod and service objects in our cluster represented here. A pod is a Kubernetes abstraction for working directly with containers. Kubernetes really thinks about containers in terms of its own pod object rather than as containers themselves. So the deployments we talked about earlier would be a higher level abstraction that manages these pods. Now you can see that each pod is running on a given node because those pods are running our containers. And like I said, they're going to have to run on some form of machines in the end. So they're running on each of these nodes. There are also services. These are the Kubernetes objects which provide a networking abstraction, allowing us to interact with those pods, with those containers. We mentioned those earlier as well. And I have them outside of the nodes because they're kind of an abstraction on a higher level than the nodes, more a part of the Kubernetes cluster itself, its own logic. So what you need to know about these highlighted red Kubernetes objects is that they are just resources for running workloads. But what I want to dive into here is the Kubernetes namespaces. These namespaces are an abstraction for grouping and isolating Kubernetes objects or resources within the cluster. Let's give them more useful names to make it clear how they could allow us to run a single Kubernetes cluster in a multi-tenant fashion. So here I've renamed our namespaces to Team 1, 2, and 3. This is one way that you could use namespaces. By using namespaces, you can assign space within your Kubernetes cluster to individual teams, as in this example. And by using RBAC, or role-based access controls, you can control which users or team members have access to which namespace. So, for example, a member of Team 1 could create and delete resources in Team 1's namespace, but could not see or interact with resources in Team 2's namespace. And this way we can create kind of a multi-tenant use case. Another way that you could do this that's very common is using prod, dev, and test on a single cluster, or that type of environment isolation. Here's an example of separating out your namespaces to use as a prod environment, a dev environment, and a test environment. So that's a little bit of an overview of namespaces, and we've gone over a little bit about what Kubernetes is. So if one cluster can be used to run workloads for many teams, and a single cluster can potentially consist of over 10,000 nodes, by the way, why would you ever want to run multiple Kubernetes cluster? Let's talk about a few common reasons that people use multi-cluster architectures with Kubernetes and use multiple clusters. So one reason that I often encounter when I talk with customers or users of multi-cluster architectures is geography, or a need to run workloads across multiple environments. If we think back to our cookie business analogy for Kubernetes, if you're running a globally distributed cookie business, are you going to have a single warehouse that manages logistics and distributes your product all over the world? You could, but this could mean more challenging shipping logistics and even potential regulatory challenges due to food safety regulations in various countries. It's likely better to have several distribution centers or management hubs located around the world. The same is true for Kubernetes. It's possible to run a single Kubernetes control plane, which is the brains of the Kubernetes cluster, that manages the compute nodes where we run our actual workloads, which are located in disparate regions. But then you would probably have some latency issues with your control plane being located, say, in North America and nodes being located in Europe or Asia. Definitely would have some latency challenges there, which would make it challenging for the cluster to operate properly. So it's definitely best to have a control plane in each region where you need Kubernetes to operate, which will mean, of course, that you're running separate clusters in each region. I also want to mention hybrid environments. This is kind of the same concept, having your control plane in Amazon and your nodes in Google Cloud or Azure or on-prem is going to create some challenges with connecting all of the pieces of your cluster, especially the networking components. So it makes a lot more sense a lot of the time to have separate clusters in each environment and then use other tooling to connect them if you need to run workloads across them, which we'll talk about more in a little bit. Now, another common reason number 2 for multi-cluster architectures here is going to be billing. So let's think about your average organization and how the management of costs within that organization works. So you have a number of teams, and each of these teams need to use resources such as compute or storage, or maybe a managed Kubernetes service in the cloud. And each of these teams need these types of resources in order to do their work. So we can represent that here. And using all of these resources, creating them in the cloud or running them in a data center, however you procure these resources, it's going to generate cost. And so in most organizations, this cost is then paid for by some form of cost center. Each team may report to a different cost center, or even if they don't, the organization will probably want to know as exactly as possible how much money they're spending on a given team. Now let's look at how this works in a multi-tenant single cluster model. Where are your costs in this Kubernetes cluster? Well, it depends a little on how you're using Kubernetes, but in most implementations, the bulk of your cost is going to be here in the compute nodes. If you're running your cluster on premises, then you have to pay for the physical machines, of course, that your cluster is made up of, including their power and cooling costs and all that comes with running those machines. If you're running a do-it-yourself cluster in the cloud, you'll probably be purchasing compute instances from whichever cloud provider you're using, and then you make up your cluster using those compute instances. So you'd be paying for those compute instances and possibly any storage resources that you want to use with your cluster as well. The majority of managed Kubernetes services in the cloud, like Google Kubernetes Engine, also derive their costs from the cloud compute instances that make up the cluster, so those nodes. So it reflects this model here. And some of those managed Kubernetes services also include a small fee for cluster management, so there may be an additional fee there in some architectures if you're using a managed Kubernetes service. The one exception that I know to this, by the way, is Google Kubernetes Engine's autopilot mode, which is relatively new. It came out in March of 2021. And it charges you based on the resource utilization, the CPU and memory utilization of your pods or workloads directly, instead of charging you for the compute instances that the Kubernetes cluster is made up of. I'm not going to dive into all of the intricacies of GKE autopilot mode or standard mode or any of the other Kubernetes managed services here. Let's just focus on this average case where most of your cost is coming from your nodes. So in this case, imagine that your cost looks something like this. Most of your cost is coming from your nodes. How are you going to calculate exactly how much each team is spending? Warning, the next slide that I have here has a GIF, so if you're sensitive to motion, maybe cover your eyes for just a second. This is probably what you're going to feel like if you try to do this model where you're using your single Kubernetes cluster in a multi-tenant way, using namespaces, and then you're trying to figure out the cost of each, the resources in each namespace. It could be a little bit difficult to calculate. So the GIF that I have here, for anyone not watching, is a GIF of a guy staring blankly with numbers flying all around him as he tries to make calculations. Which, like I said, is probably what you'll feel like if you try to do this approach and need to calculate the costs. Of course, if that's not a concern of yours, then maybe that doesn't matter to you. But for a lot of organizations, this is a concern. So GIF is gone if you were covering your eyes. Now, if we want to make our Kubernetes architecture match the way that cost is structured within the organization, we'll need to make our approach better match the organizational model. Gotta build it all out. The organizational cost model that we talked about earlier. So, broke my automation here a little bit. Now, it's pretty common to take this type of approach in order to better match this cost model. In this diagram we have here on the slide, you have one cluster per team as it relates to your org's billing structure. So I have seen some evidence that using the single cluster multi-tenant approach results in more efficient utilization of the resources of that cluster, which of course has the potential to save you some cost. Also, if you're using a managed Kubernetes service where you have a cluster fee per cluster, not all of them do, I don't think, but you'll have to check specific implementations of managed Kubernetes offerings to see if they do. But if you're doing that, then obviously each cluster will incur a slight additional cost there as well. So there are some cost concerns with this model that might be a little bit different. But if it better suits your organization's cost model, often that's preferable choice that makes things a little bit easier to organize and calculate. So whether you should use a cluster per team or use namespaces and a single cluster multi-tenant model depends on your environment and your restrictions and what you need to work with. So as always, the answer is it depends. But this billing structure consideration is certainly one reason that some companies use multiple clusters. Now, the next reason that I want to go over is security boundaries. Another colleague pointed this out to me when I asked him to review this presentation, and I thought it was a great point. The multi-tenant single cluster model means that you'll have to consider the security implications of namespace boundaries using role-based access controls within the larger cluster security boundary. Using the Kubernetes cluster boundary as the primary security boundary kind of simplifies this consideration. And so for some use cases where you want to have a really clear boundary with this is my security boundary for these workloads, sometimes it's preferable to use a single Kubernetes cluster instead of using the namespaces, where you have to think a little bit more about how namespaces and role-based access control work together within your Kubernetes cluster to create that security boundary. Not to say that one is better than the other. And again, it depends on your use case and what you're trying to accomplish. If you want to use your resources really efficiently, namespaces might be a good option. If you care less about that and care more about a really simple, clean security boundary, maybe per cluster is a model that makes more sense. But that might be a reason to use multiple clusters. And another reason that is really obvious, so I want to mention it, but it's really not very common, is, of course, scale. I mentioned earlier that a Kubernetes cluster can potentially consist of over 10,000 compute nodes. The networking requirements of a cluster that large are pretty difficult to manage. So they're quite rare for that reason, and also just because it's pretty rare to have a set of workloads that you really need to run on a single cluster that will approach that size. So it's pretty rare for a cluster to approach the higher reaches of a cluster's limits in terms of the scale of its nodes. But there are such cases. They're pretty rare, but they do exist. And so when a single Kubernetes cluster isn't enough to run your workloads like you want to, then of course you're going to need more clusters. So like I said, a pretty rare occurrence for you to not have enough compute nodes in your single Kubernetes cluster to manage the workloads that you need to do. But it can be a concern depending on how you architect things. Pretty rarely. So let's review. Our reasons for multi-cluster are geography or hybrid environments. You'll probably want a separate cluster in each environment or region for either latency or regulatory requirements or what have you. Billing, your billing model within your organization and matching your resource usage to that billing model is another reason you might need multiple clusters. And security, having a simplified security boundary of the Kubernetes cluster itself rather than the slightly more complex security boundary of namespaces within the cluster in a single cluster multi-tenant architecture. And every now and then you might have a case where scale is a reason to have multiple clusters. So of course there are a lot of reasons that we've gone over here why you might want to use multiple clusters. So let's now talk about what multi-cluster looks like in Kubernetes. First thing that you need to understand is the Kubernetes open source group's approach to multi-cluster architectures and how it thinks about them and how it looks at creating new tooling to help users who need to run multiple clusters, especially when they need to organize workloads across all of these clusters. So SIG-Multicluster, or the Special Interest Group for Multicluster, is the group that's focused on how to expand these Kubernetes concepts and use beyond the cluster boundary. Historically, Kubernetes clusters have been the end of the universe. Everything exists within the Kubernetes cluster as far as Kubernetes is concerned. Because everything is contained within this universe, which is a cluster, clusters don't really know anything about themselves or others. For example, they don't have cluster identifiers, or they haven't historically, because if everything is contained within that cluster, then you know who you're talking to, and there's no need to identify yourself. This, of course, becomes a problem when you begin to spread your deployments across clusters, and SIG-Multicluster is the group of people focused on figuring out how that should work while maintaining the same portable and flexible philosophies that have built Kubernetes clusters as they exist today. So when you're thinking about multi-cluster capabilities in Kubernetes and how they work and who's thinking about them, this is who it is. And you can find them on Slack if you ever want to chat with them and help them out with their work. They would love to have you. So let's talk about what SIG-Multicluster is working on these days in terms of multi-cluster architectures with Kubernetes. What capabilities do we have? The strategy of SIG-Multicluster has evolved over time. In the early days of the Kubernetes project, the maintainers knew that eventually users would have needs around managing multiple clusters. But in the early days, this wasn't a major problem for Kubernetes users. As adoption has grown, and especially as very large enterprises have begun to use Kubernetes extensively, these problems have started to become more and more relevant. Initial attempts to solve these challenges were rough and mainly theoretical, as the use cases just weren't there yet, because as I said, in the early days, users just weren't encountering these issues very much. The Kubernetes contributors and maintainers knew that these issues were going to pop up, but they hadn't yet. So the earliest attempts by SIG-Multicluster to solve the problems of multi-cluster architectures was a tool called KubeFed, which was focused on the concept of federating or managing multiple clusters, and in kind of a prescriptive programmatic way. But as I said, it's kind of based on this theoretical logic of what the maintainers thought would be needed, rather than on real-world use cases of users who are trying to use Kubernetes in a multi-cluster fashion. Over the last year or so, real-world use cases have started to appear and become more urgent. So as these use cases have revealed flaws in the original federation model, SIG-Multicluster has developed a new strategy to more directly solve the challenges of real-world multi-cluster use cases. At present, the two key parts of this strategy are a pair of APIs called Multi-Cluster Services and Gateway API. Both of these efforts provide a standard, but not an implementation, of an API. And their goal is to allow users to interact with their workloads and networking in a consistent way, regardless of what environment they may be running in. So this means that the implementation of these APIs may vary from cloud provider to cloud provider or environment to environment. But what SIG-Multicluster is trying to do is provide you with a common way to interact with multi-cluster networking and service concerns, regardless of what environments you may be running in. So let's recap what we've gone over today. I know that was kind of brief and quick, but I hope it's given you a good view of what's going on today and how we got here. So what is Kubernetes? We talked about how Kubernetes itself is a tool for running containers, container logistics basically, at scale. And it abstracts away the underlying hardware so that you can interact with this single Kubernetes cluster concept. And like I mentioned, the APIs that Multi-Cluster is working on, they're kind of trying to reflect what Kubernetes has done with abstracting away the underlying cluster and giving you a single way to interact with it that can run on any kind of environment. They're trying to reflect that, but make the networking concerns of networking multiple clusters together more both flexible and consistent for the user. Now, multi-tenant Kubernetes clusters can be run. You can basically run Kubernetes in a multi-tenant fashion by using namespaces and role-based access controls, which may be a more efficient way to manage your Kubernetes architecture, but it has its drawbacks. And we talked about the reasons that you might want to run multiple Kubernetes clusters, namely cases where you need to run a workload in many regions or geographies or environments. And when it comes to organizing your resources to match your organizational billing model, that might be a reason for multiple clusters. And when considering your simplest options for security boundaries, you can of course do the namespace route, but you'll have to have a little bit more understanding of how you can use namespaces and role-based access controls to create that security boundary. And maybe in some relatively rare cases, when the scale of your workloads is just too much, even for clusters consisting of over 10,000 compute nodes. So you might want to consider using multiple clusters. There's a special interest group within the open source Kubernetes project that we talked about, whose goal is to think about and provide solutions to the challenges that come with running workloads on multiple clusters. Specifically, their current strategy relies on these two key efforts: the Multi-Cluster Services API and the Gateway API. Each of these provide a standard way to manage the networking challenges when managing workloads across multiple clusters, though the implementation will need to be provided in a form that's more specific to your environment. So if you want to check these things out, you can check them out on GitHub. There's within SIG, Kubernetes SIGs, I think is the repo on, or the kind of group within Kubernetes or within GitHub. And then you find the multi-cluster SIGs GitHub. They have all the information about the Multi-Cluster Services API and its implementation. It's implemented as a custom resource definition within Kubernetes, if you're familiar with those. It's basically a way to teach Kubernetes how to do something new, create your own objects in Kubernetes. And that's what they've used to create this new API for managing services. Your Kubernetes service objects, by the way, is what it's referring to here, I think. And that's my understanding of it, at least. It's taking your Kubernetes service objects, basically, and making them available across multiple clusters using your networking. So it's a really cool implementation. It's still relatively new, so definitely check it out on GitHub and chat with them on Slack if you're interested in learning more details or maybe contributing to it. So that's your basic introduction to running Kubernetes at scale using multiple clusters. I hope you enjoyed the session and learned something new. I know it was quite a bit of information, but still kind of only scratching the surface. So feel free to reach out to me. Feel free to reach out to me on LinkedIn or on Twitter at Kaslin Fields, or use whatever feedback capabilities this event is providing you. And I'd be happy to talk to you. Or like I said, reach out on the Kubernetes Slack. We're always happy to help and help you find more resources to learn. So thanks for watching.